All right, let's look at some more applications of the normal distribution. It says birth weights are normally distributed with a mean of 7.52 and a standard deviation of 1.09. A hospital wants to set up a special observation area for the lightest 2% of babies. What weight should be the cutoff? So the lightest 2% of babies, we know that 7.52 is going to be our mean, right? Where would the lightest 2% of babies fall? They're going to probably be somewhere down here. Here, let me use a different color for this. The lightest 2% of babies would probably be maybe this little piece right here, give or take. So this would be the lightest 2%, right? Now what we want to know is, what is that cutoff? Now, you might be thinking to yourself, wait, I don't know what to put in here for that lower limit, and this is where you should stop and think about this and say, okay, I'm not going to be using the normal CDF function. When I'm given percentages like 2%, I'm going to use the inverse normal. So let's look at the inverse normal function and see what it wants us to, what information it wants. When I take a look right here, it wants the mean, which I know is 7.52. It wants the standard deviation, which was 1.09. Let me just double check. 7.52 and 1.09. And then it wants the area, which we said was 0.02. Be careful, it's not 0.2. We have to divide that by 100. So the area is actually 0.02. And now take a look right here. Would this be a left tail or a right tail? What's shaded to the left, so that would be a left tail, or shaded below. So I'm going to go to my Excel spreadsheet and I'm going to read, what is that value for the left tail? Make sure you hit enter there. I was confused. Okay, so for the left tail, it would be 5.28. So again, let's not worry about this. That number right there would be 5.28. We know that value now. So the weight that should be used for the cutoff for the lightest 2% of babies is 5.28 pounds. All right, let's take a look at another one. It says the average height of women is 65 inches with a standard deviation of 3.5 inches. If the U.S. military services wanted to change the height restrictions so that it excluded the shortest 3% of women and the tallest 4% of women, what would those height requirements be? Let's shade this situation. So we know we're going to have 65 in the middle, right? We want to exclude the tallest 4% of women, so that's going to be 0.04 right here. And we also want to exclude the shortest 3% of women. So 3%, that's going to be this value right here, right? We know our mean is 65, and we know our standard deviation is 3.5. Now, this we're not going to be able to do in one step, are we? We're going to need to do the inverse normal function twice. Once for this one, which is our left tail. So let's go find that one. I go to my Excel spreadsheet. I enter my mean, which was 65, my standard deviation, which was, 3.5, and then we're going to change that value to 0.03, right? Because we're looking for that left tail, so the shortest 3% of people. And that number would be 50. Let's round it to a whole number. That number would be 58. And now the tallest 4% of women. The tallest 4% of women, the mean stays the same, the standard deviation stays the same. We're going to use 0.04. And then remember, is this a right tail or a left tail? Since this is a right tail, we're going to make sure we read that value off the Excel spreadsheet. So the right tail is 71. So if we only wanted to if we wanted to exclude the shortest 3% and the tallest 4%, this height range would be 58 inches to 71 inches.